Hello and good day, pre-algebra. Today we'll be going over math packet number 5, kind of give you some tips and tricks that you can use as you work through the problems yourself. Note the due date, December 18th. That is the day before we leave for Christmas break. So if you know that you're not going to be here that day, then turn it in the 17th or the 16th or whenever you will be here. So as always, we start with kind of open-ended logic questions here. And it says, Les, Quinn, Sherry, and Nate shared a box of pencils equally. So for starters here, we've got 4 people that are participating in this sharing of the pencils, okay? Quinn then shared all the pencils he got equally with 5 other friends. So kind of what's going on here? You've got Les, you've got Quinn, you've got Sherry, and you've got Nate. Okay, they shared a box of pencils equally. We don't know how many pencils are in the box, but that's kind of what the question is. Okay, so they all have the same number of pencils, but then Quinn shared all the pencils he got equally with 5 other friends. So now Quinn breaks his pencils, right, into 5 other people. Okay, if Quinn and each of his friends got 3 pencils, how many pencils were in the box? That's kind of the key phrase here. If Quinn and each of his 5 friends, if they each got 3 pencils, how many pencils were in the box? So this is kind of a working backwards. You know how many pencils Quinn and each of his 5 friends have, right? So then you can work it back to, well, how many pencils did Quinn have before he shared? And then how many pencils were in the box altogether before Les, Quinn, Sherry, and Nate shared them all amongst themselves. All right, so I think that will get you started there. As always, make sure that you are explaining why your answer makes sense, whether it's verbally or you put something in your calculator, show me the calculation. Just explain it. Give me some defense of why your answer is correct. Scroll down to the next one. Hannah gave Jane as many books as Jane already had. When Jane received these books, she asked Hannah how many books she had left. Jane then gave this number of books back to Hannah. Hannah then gave Jane back as many books as Jane had left. This left Hannah without any books and left Jane with 80 books. How many books did Hannah and Jane have to begin with? And your hints, just kind of like the first one, is to work backwards. Wow, this is a lot of words here, okay? But basically what's going on here, just kind of explaining this first sentence. Hannah gave Jane as many books as Jane had already. This isn't the answer. This is kind of explaining what's going on here. But what this is saying is that, let's just say Hannah had 10 books and Jane had 2 books. When it says Hannah gave Jane as many books as Jane had already, if Jane already has 2 books, that means that Hannah is giving Jane 2 of hers. Right? She's giving Jane as many books as Jane has already, which is 2. Which would leave Hannah with 8 because she gave away 2, and it would leave Jane with 4 because she gained 2. Right? So that's kind of what's going on here. However many books Jane has, Hannah gives Jane that same number. Then it says when Jane received these books, she asked Hannah how many books she had left. Jane then gave this number of books back to Hannah. So they're constantly exchanging books, and each person receives the same number as they already have. When all is said and done, though, takes forever to erase here. When all said and done, it said this left Hannah without any books and left Jane with 80 books. So at the very end of this, right, they trade. At the end of it, Hannah has 0 and Jane has 80. So you need to think about that and look at the line before where it says Hannah then gave Jane back as many books as Jane had left. How many books would Jane and Hannah have each had to have in the step before this so that Hannah gives Jane all of her books? It'd be left with 0. Well, in order for that to happen, Hannah and Jane would each have to have 40, right? Because if Hannah then gave Jane back as many books as Jane had left, that means Hannah is giving Jane 40 books, because that's how many books Jane has, which leaves Hannah with 0, because she gave them all away, and it leaves Jane with 80, 40 plus 40, right? So you're kind of working backwards through each level here to figure out, well, how many books would they have each had to have to start with to make the sequence of events occur and be left with 0 for Hannah and 80 for Jane. Okay? This one's a little bit of a thinker, all right? So give it some time, okay? Try some things out and see what you can come up with. 5-card challenge, don't really need to talk about this very much, I don't think. You know how this works by now. Just make sure that you are getting at least 15 points. You've got a 6, a 9, a 5, a 4, and a 3 to make a 5. There are some opportunities for 1s. We always like to see that because they do help us. We can multiply by 1, divide by 1. The value doesn't change. But yeah, 5-card challenge there. Next one, find the perimeter and area of the figure. The figure contains a semicircle, a top, a rectangle. Round your answers to the nearest hundredth. All work must be shown. All right. So here's where we, I think it's our first experience with circles. I think all of our previous perimeter area questions were all with kind of rectangular, boxy things. But now we have a circle. So the perimeter of this figure is going to be the distance around the outside like you're used to here. But now you got this hump in the middle. Whoop. Okay. What I've outlined there in green is the perimeter. And it's pretty easy to get the outside lines of that rectangle. It's the circle part that's probably going to be new. And if you've heard the word circumference before, the circumference is the distance around the outside of a circle. It's kind of like a circle's perimeter. The formula for the circumference of a circle is pi times the diameter. Pi times the diameter. Now, what's the diameter? No doubt you've heard that word before. The diameter, I'll draw it here in blue. The diameter is the segment that goes from one side of the circle through the center of the circle to the other side. And how we know that it's passing through the center is that naming this a semicircle means it's half a circle. So this point right here is going to be the center of that circle, and the diameter is passing through it. So you need to figure out what's the length of that diameter. Use the other clues, use the other measurements given to find out the length of that diameter, and you're going to plug it in to our formula, circumference equals pi times d. But here's the thing. We don't want the whole circumference of a circle. We only have half. So in this case, once you find pi times d, you're going to want to divide that by 2 because you only have half a circle, right? Pi times d would give you the circumference of an entire circle with that diameter, but we don't want that. We only have half a circle. So you're going to want to divide that number by 2 to get the circumference of this semicircle. And then, of course, you're going to add that to the other measurements that you have for the rectangle to get the perimeter of the entire figure. Okay. As far as the area is concerned, well, you have the area of a rectangle here, right? That's just your standard rectangle here. You know how to find that. Area of a rectangle is base times height. The area of a circle, however, and maybe some of you know this formula already, is pi times the radius squared. You square the radius and multiply it by pi. Well, what's the radius? Well, the radius, I'll draw it in black here. The radius is a segment going from the center of a circle to the edge. So it's essentially half the diameter. So whatever the diameter was that you found to get the circumference of the circle, you're going to want to take half that diameter, and that's going to be your radius. Okay, that value gets squared, multiplied by pi. But again, because we only want the area of half of a circle, we're going to take that number and divide it by 2. If we had a full circle, it'd just be pi r squared, and that'd be the area, and we'd be done. Okay, but because it's a half a circle, we're going to need to divide it by 2. And then that gets added to the area of the rectangle that you have there. So a little bit something new here, okay? An introduction of circles, perhaps. If you find yourself having issues with this, then of course, I will be a resource for you. So there you have it. Next one, our pattern block figure. It says pre-algebra, complete the table. Okay, so your job is to find the number of blue, red, and total blocks in each figure up through figure 10. You don't have to do this section here. That's for geometry only. So let's look at kind of what's happening here. Okay, the first 4 figures are given, and it's pretty easy here to count the number of blue blocks. Looks like we go from 3 to 6 to 9 to 12. You can probably already, see a pattern developing there. The number of red blocks looks like we have 3, 6, 9, 12 in the first one. Then we have 4, 8, 14 in the second one. Third one here, we have 10, 16. And I'm guessing the next one's 18. Let's see, 12 and 18. Yeah, so we have a pattern developing there as well. 12, 14, 16, 18. And then the number of total blocks is just going to be the sum of blue and red together. 3 and 12 is 15. 6 and 14 is 20. 9 and 16 is 25. 12 and 18 is 30, and so on and so forth. Okay, we can prove our total blocks are correct also by finding the area of each figure here. 3 times 5, 15. That's what we got for the total blocks there. 4 times 5, 20. That's what we got for the total blocks in figure 2. 5 times 5, 25. That's what we got for the total blocks in figure 3. And 6 times 5, 30. That's what we got for the total blocks in figure 4. Okay, so I think you are ready to go on that one. Next up, we have surface area. More dealing with circles here. We've got a cylinder. And perhaps, you probably have not worked with surface area of a cylinder before. Maybe you have. But let's kind of pick this apart. What shapes make up a cylinder? And a great comparison of a cylinder would be like a soup can, right? If you kind of, use a can opener and take off the top and the bottom, you've got 2 circles, right? Top circle is much better than my bottom circle there. And then if you peel off the label, which wraps around the can, what's that label going to look like? Well, it's going to be a rectangle, isn't it? Right? So a cylinder is essentially 2 circles on the top and the bottom of a rectangle. And if you kind of imagine us putting this back together, folding the top circle and the bottom circle down, and then wrapping that rectangle around the edge, you're going to get yourself a cylinder. And so for surface area, we're going to need to find the area of the 2 circles, which will be the same, right? And then the area of that rectangle in the middle. And if you recall, the area of a circle, we talked about this with perimeter area, is pi r squared. That radius is that segment that goes from the middle to the edge, so that's given to you there, right? So that's how we find the area of the circles, but what about that rectangle? Well, this 40 represents the height of the rectangle, so we can put that in there. But how do we get the base? How do we get the base? Well, notice that I'll trace this in blue here. The base of this rectangle is what wraps around our soup can or wraps around our top circle. So the length of the base of the rectangle is going to be the same as the circumference of the circle. And if you remember the formula for circumference, pi times the diameter, well, if the radius is 25, what's the diameter going to be? Right? That relationship between a radius and a diameter, radius is half the diameter. So what is that diameter going to be? Okay, so finding the circumference of that top circle, and this time we're not going to divide by 2 because we want the whole circumference, we want the whole circle. We don't only have half of it here. But the circumference of that circle is how you're going to get the base length of that rectangle in order to find the area, okay, because of how it wraps around it. All right? If you have more questions on that, certainly do come and see me. The next page we get to volume, and we have that same cylinder here. So the formula for the volume of a cylinder is kind of similar to the formula for the area of a circle. It starts with pi r squared. But then the difference between a cylinder and a circle is that if you think of like a pancake, a pancake is basically a circle. But if you stack a whole bunch of pancakes, one on top of another, you're going to get a cylinder. So the added dimension to go from a circle to a cylinder is height. So we're going to take our pi r squared and we're going to multiply that by the height of the cylinder. That's what makes it a three-dimensional shape. So the calculation we will perform to find the volume here is we're going to take pi times the radius squared, the radius being 25. We're going to square that, and then we're going to multiply that by the height, which is 40. And if you do that correctly, I'm going to use the exact value for pi using the pi symbol on my calculator. If you use 3.14, the answer that you get will be slightly off, okay, but it's not wrong. It's that you use 3.114 and I use the exact value for pi. But pi times 25 squared times 40, 78,539.82, and we always want to round to the nearest hundredth. And this is in inches, so cubic inches. That's the volume of that cylinder. That's a lot, okay? And then your question, once again, I guess you're probably thanking me for always forgetting here to take out that surface area question since you found it on the previous page. But for you folks, what is the surface area of the figure? That is the answer that you put down below. Next one, math exploration, multiple patterns within Pascal's triangle. Again, looking at Pascal's triangle, just a tremendous pattern, tremendous mathematical relationships here. It says using a pencil, shade in the elements that are a multiple of 2. There are multiples are what numbers can go into. So what numbers can 2 go into? 2 can go into 2, and 4, and 6, and 4, and 10, and 10, and 6, and 20, and 6. Basically all the even ones, right? So nothing in that row. This row, we can go in all of them. Next row, skip 9, all my even numbers here. Okay, next row, 10, 120. Okay, and you're starting to see some patterns develop here as I go through. It's getting kind of, hopefully these numbers are easier to read on your page. And again, we have the symmetry of Pascal's triangle. Let's see, almost done. Is there anything in here? These all look to be odd numbers there. And then the last row, but they're all going to be even. Okay, so we kind of see some patterns develop here. You got kind of like a triangle shape in the middle here. Right, you got the makings of a triangle here, though incomplete without 3, 5, and 15. You've got some triangle action going on here, there. I bet this is going to be, kind of the start of a big triangle going down like that. So what I wanted you to do here is go through each of these, and the next one, shading the elephants that are multiples of 3, then 4, then 5, and take a look at the different patterns that you see develop here. It's pretty neat. Okay. Mean, median, mode. I believe this is not the last page, second last page. It says in the table below, looking at pre-algebra here, record how many hours you sleep each night for 7 consecutive nights. So hopefully you've already started this since it is Friday night tonight, and these are due next Friday. If you start tonight, you'll end next Thursday, which will be perfect. You have the day. You can put the date in there. So if you do start tonight, it would be 12/11, right? And the number of hours of sleep that you get. You can round to the nearest 15 minutes. So if you get, for example, 6 hours and 15 minutes, that'd be 6.25, right? The 25 is because 15 is a quarter of an hour. If you get 8.5 hours next night, you're at 8.5. If you get, 9 hours and 50 minutes, you could round that to be 9.75, right? 9 hours and 45 minutes, or 9.75 of an hour. So calculate that, and your job is to find the mean, median, and mode of the data. You do not need to answer this question here. I'm just looking for the mean, median, and mode. And finally, we have our polynomial question. The 8 polynomials on the left appear in the diagram on the right exactly as they are positioned. So no rotating, no turning, no flipping, nothing like that. Okay? You need to identify where they are. And again, mind your shading. If I get something that looks, kind of like this, and I can't tell where one block starts and another block ends, I can't give you a credit. So some people like to, if you think that that this block goes right here, just kind of draw it in there, right? And then if you think that this one goes right there, kind of draw it in there. Of course, that's not the correct way to go, so don't copy that. But that's one way that you can mark the block so I can easily see it. It doesn't get all messy with shading and stuff. So anyway, that is math packet number 5. It is due the 18th. You can turn it in early for me to check over. Highly recommend that. If you have any other questions on it, please don't hesitate to ask. My email is always open if you are working on it over the weekend. Have a great weekend, and I will see you on Monday.